Hey y'all, it's your math teacher Mr. Boyden back at it again, and today we're going to talk about parent functions and how to graph piecewise functions. So what's a parent function? A parent function is basically just like our building block function. They're like Legos, okay? We can put them together to make other things. We can transform them to meet our needs for any situation. Well, not any, most situations. So what we're going to do is we're going to roll through pretty quickly what the different parent functions are. Today, I would suggest that for every graph we make, and you're going to see all the equations here, I'm going to suggest you go to a website called Desmos.com. Okay, I have no stake in Desmos. I do not make money when you go there, but guys, it's a really good website for graphing. It's very user-friendly. Also, it works really well on mobile devices, and they have a mobile app. I recommend you download it. It's a free download, takes up a little bit of space, but it's a really slick and easy way to graph stuff. So highly recommended, Desmos.com. Okay, so here we go. First one is called the constant function. The constant function, it's this little red line right here. It's a line, and it's horizontal. And so what we really mean when we say f of x equals c, c is a number. So like this particular case, this is the function y equals 5, if you wanted to graph it. Okay, make sure you get that in your notes. What about the next one? Linear functions. Okay, we've all seen those from algebra class, both algebra, our first year algebra and our second year algebra course. So we have the linear function, and we know that it can have all kinds of different slopes and y-intercepts. We may or may not have seen the absolute value function before. This is kind of a fun one, makes a little bit of a v. Notice that here on the right, it has a slope of 1, and here on the left, it has a slope of -1. We're also going to deal with quadratics. You've probably seen this one before as well. Okay, that one's x squared. The shape is called a parabola. The equation is not a parabola equation. It's an equation that is quadratic, which produces a parabola. Now, I do want to talk about one thing. The word quadratic, and this used to really confuse me when I was learning how to do quadratic functions. I would think, I know that quad means 4. So what the heck is that 2 doing right there if quad means 4? Okay, guys, what it comes from, there's a Latin root, or like there's an Italian word quadrato, which means square. Like literally quadrato means square. So that would tell us that quadratic would mean a function that does squaring. And so there it is. It's just a function that does squaring. It's based on a Latin root that does not, from what I can tell, has not made it into the English language. Okay, we also have the cubic function, x cubed. One thing I'd like you to think about is, in what ways is this similar or different than the quadratic? It goes up and to the right, just like the quadratic did, and the quadratic would come up and to the left, but this one goes down and to the left. It's like the left side just got droopy. Now, it's not exactly a parabola that's half flipped. This actually increases at a much faster rate than a parabola, but similar in concept because they're part of the same family, the family of polynomials, which we'll learn about in the next unit. Okay, everyone's favorite, the radical function. Okay, so you may want to make a sketch of this one. Goes up and to the right and kind of curves out to the right. Be careful, some people draw it like it curves toward going upward, but it is going upward, but it curves way out to the right, and it's going more right than up. Okay, and then finally we have the reciprocal function. Now this one's really interesting because it has 2 different chunks, and this is our first discontinuous function, meaning it's not just one continuous flow to draw it out, right? It's got one chunk here. I have to lift my pen to go up here and continue drawing, okay? So that's our parent functions. Now, with our parent functions, let's try to identify some children. So we have some wandering, lost little children. So who is this one's parent? Well, take a look back at what you wrote in your notes. What does this look most similar to? It doesn't look exactly like any of them, but it has a lot of the similar characteristics of x cubed. It's going up on the right, it's going down on the left. There's some sort of a squiggly thing in the middle. Another one we learned about kind of looked like this. So still there's some sort of an S curve in the middle. This has a kind of an S curve too. This absolutely has the parent that is x cubed. What about the next one? Okay, this one's a little bit easier. This one's just a parabola facing down, so that's an x squared. That's a quadratic. What about this one? This one we're dealing with a radical function, okay? Because normally the radical goes like this, and you can see it's that same shape, it's just flipped down. And what about here? Oh, this one's an easy one, okay? This one has the point. It's the only one that has what's technically called a cusp. That'll come up again in calculus if you take it. You don't need to know it for pre-calc, but for calculus for sure. So it has a cusp right there, and that's going to be a dead giveaway that this is an absolute value graph. Okay, so now we're going to practice graphing piecewise functions based on all the stuff we've talked about in this unit. So you may want to take a minute. You're probably going to need graph paper for this next section, or you're going to have to be really meticulous with how you graph this stuff. You may want to take a minute, pause the video, and jot down this right here. And y'all, you're going to have to do some pausing because I'm not going to pause and give you time to write. So take as much time as you need, okay? So for this one, we just want to write down the piecewise function. I'm going to call it f of x, and it's piecewise. And what I see is that it has 1, 2 pieces. And they were nice enough to give me the function names, which is super nice. So the first function is 5. And just so you know, we're always going to start with the one on the left. Okay, this is to the left of that. So we're going to start with the one on the left. So put a comma. And then we have to describe for what x values is this function the one that's being graphed? Well, it's over here on the left side of the x-axis. So certainly for negative x values, so that would be x is less than 0. I might have to revise that in a second. And then we need to think about what does that mean right there? Does that mean that point is on the graph or that point is not on the graph? And for contrast, we can compare it to this one right there. So here's what you got to remember, y'all. If it's an open circle or an unfilled dot or whatever you want to call it, that means that the symbol that produced it was either one of these or one of these. Because this is saying that point is not actually on the graph. We're not including that point. So that's why it's a less than or a greater than, rather than a greater than or equal to or a less than or equal to. Now, if we're going to do a greater than or equal to, less than or equal to, we're going to go ahead and fill in the dot and say, yeah, that point's here. Okay, that point exists. Now, the trick that helped me understand it when I was learning this is my teacher said, look, this one, they did not use the ink to fill in the bubble. So we're not going to use the ink to put the bar underneath. In this one, they actually used the ink to fill in the bubble. So yes, we're going to use the ink to put the bar underneath. So for us, they didn't use the ink. I'm not going to use the ink. I'm good. Let's go to the next one. X squared. And then we have to figure out for what x values does this work. It's only going over to the right. So that would be for x that's greater than 0. And then notice the symbol. What does that tell me to do? That's filled in. So I do need the bar underneath. This is an inclusive inequality. Okay, and that's it, because that's all it is. So the next 2 examples, we're going to work the same process backward. We're going to be given the function, and we're going to create the graph of the equation. So you may need to pause the video and write that down now. I mean, write this function down here. Okay, I'm going to start graphing. Okay, and there's a process that I always use to do this. What I do is I just start from top to bottom, which will make my graph go from left to right, which is good. Okay, so what I do is I'm going to take this value and I'm just going to automatically plug it in over here. So I'm going to say I want x to be -1. If x is -1 and I'm plugging it in here, I get negative, -1, which would be 1, which gives me the point, -1, comma 1. I'm looking right here and I see that there's no bar underneath, so I'm not going to put a dot, I'm going to put a circle. Oops, and then I messed it up just like that. I'm going to put a circle. There we go, that's better. Okay, now I'm looking right here and I see that this function appears to have a parent which is linear, which is good. It tells me it's a line. The question is, do I know how the line goes right now? As a teacher, I do, but you may not. So I'm going to show you what to do if you don't know. You can always just pick another x value. Now in class, people were saying like, oh, pick 2, pick 2. Guys, I can't pick 2 because 2 is not less than -1. It's not in the domain of the linear part of the function. So I have to pick an x value that satisfies this, like x equals -5. And then I get -5, which equals 5. I did not break any rules by plugging in a -5. So that's going to be a dot. So left 5, up 5. There's a dot. And so now it's a line. I know 2 points. That's enough information for me to put my line in. And please excuse my, my lack of accuracy on this drawing pad. It's not very good. I'm trying to make that a straight line. Okay, so that first chunk is done. So what I do is I put a line here, recognizing really this is 3 math problems we're going to do. My first one is done. Now I'm going to go to the second one. In the second one, I'm just going to repeat the process. I'm going to plug in the numbers I was given. So I'm going to plug in -1, and I'm going to plug in 2. So here we go. That would be 4 over -1, which equals -4. And I plug in a 2, and I get 4 over 2 equals 2. And so let's plot those points. -1, -4. And it looks like I am going to be filling in my dot because of that guy right there. And then 2, 2. And it looks like I am leaving that open because there's no bar underneath there. Now, the question is, do we know how to connect those dots? Some people will just draw a line between them, but you have to look back and say, what is the parent function? And that is a reciprocal function. So maybe I say, I'm not feeling too confident. I need my memory jogged. So I'm going to pick a number that's in between these two to plug in. Now, if I plug in 0, that's 4 divided by 0, it doesn't work. Hey, that reminds me, that means there's no points along the axis here. But I could plug in 1, so I'm going to do that. And then I get, oops, arrow, and then I get 4 over 1, which equals 4. So I get the point 1, 4. And that reminds me that, oh yeah, it does this. It goes up and gets closer and closer, and there it is. And that reminds me, oh yeah, this is going to go down like that, just like the parent function did. So now my second chunk is done. Oops, didn't mean to cross it out. I'm just trying to block these off. Now I can go to the third chunk, and I'm going to plug in the number they gave me. So I'm going to say, okay, x equals 2. I'm going to plug in a 2. That'd be the square root of 2 times 2, which is square root of 4, which is 2. Now that's interesting. We already have that point. And here it says we're going to fill it in. So y'all, we're just literally going to fill that in. Now, if you want to go plug in more points, you can. I'm not going to. I'm going to remember that this guy, actually the graph kind of looks like a radical, doesn't it? It kind of did one of those things. Kind of looks like the root. I'm going to remember that it just goes like that. Now, if you're in my class, actually I'm going to do a little better job of drawing that. If you're in my class, then here's how I grade these. Okay, what I want to see is that you have the proper endpoints, okay, and they're either filled in or not. And then in between the endpoints, I want to see that the graph has the proper behavior. Now here's what I mean by that. This is linear. It needs to look linear. This is a curve. It needs to look curved. This is a curve. It needs to look curved. If you demonstrate those things, then you're demonstrating understanding. That's our whole graph. That's our first one. Let's try another one. Now, if you feel really good, when you pause the video, also try graphing it. Okay, see if you can graph this one on your own, and then you can get some feedback. Okay, so if you're ready, let's get started. I'm going to start by plugging in. Oh, sorry, there is a typo in this one. That needs to be a -2. Okay, so please make that fix right there. I'm going to plug in a -2. And let's see what I get when I do that. I get the absolute value of -2 plus 2, which is 4. So I get -2, 4. I'm filling it in because I have an inclusive inequality. And the question is, do I know what the other points on this graph are? I'm not sure. And so, y'all, one of the things I've seen in the past when I grade these, people go, oh yeah, I know that makes a V. So boom, there's a V, and they call it good. No, 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 no. That cuts off at -2. You can't do that, okay? So what we could do, we could pick another point like, again, I'm going to use the same one as last time. How about -5? And then I get -5 plus 2. Don't forget the absolute value. And that's 7. So I get -5, 7. Then I go, okay, I feel pretty good. It's just going to go up like that. Okay, and that's an arrow on the end, okay, if you can't tell. Okay, let's go to the next chunk. And I like to block them off. That helps me follow my work a little bit more easily. So I suggest you do that as well. Block off different parts of your work. Okay, I'm going to plug in a -2. And I'm going to plug in an x equals 1. So let's see. I get -2 squared and 1 squared, and they both have a +3. So let's see. That's 4 plus 3 is 7. And 1 plus 3 is 4. So let's go ahead and connect the dots there. So I get -2, 7. And that's open because there's no bar underneath. No bar underneath there either, by the way. So then I'm going to go down to 1, 4. And the question is, how do we connect those? Now you look and say, okay, I know the parent function is quadratic. So I know that's a parabola. But the question is, how low does the parabola go? I don't know. So let's pick a point, like an easy one, like x equals 0. 0 squared plus 3 equals 3. Because here's what's important. People say, oh, it's a lot of work. It's not a lot of work. Okay, it's really easy. You plug in a 0, and you get another point, and you go, oh, now I can see it's going to curve down like that and curve up to there. Okay, so now we've demonstrated what I'm looking for when I grade. You've got your proper endpoints. You have a proper curve in between them, and that's done. Okay, so that's our second chunk of work. Let's go to the third chunk. For the next one, let's plug in an x equals 2. It says when you plug in a 2, you get out a 2. Hey, what about when you plug in a 3? You get out a 2. All right, so that already gives me a pretty good idea of what's going on. The parent function here is the constant function. It's going to be a horizontal line. So I'm going to come to 2, 2. I'm going to put a circle, because I got no bar underneath, and it just goes out to the right. And that's it. Okay, so that's a basic process for how to graph piecewise functions. Anytime you get into trouble or you're having difficulty, please, 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 pick an extra x value or 2. I did it 3 times in this example. Pick extra x values so you can get more information about the behaviors of the graph, and your graph will become more accurate. Okay, that's going to be all for today. Hope you enjoyed the video, and we'll see you next time.